This video will be about the scientific method, or just for fun, important things to know about how we find out about stuff. It's important to understand that the way we go about finding scientific knowledge hasn't changed a whole lot over the past couple hundred years. Granted, technology has changed a great deal, giving us new and better tools to find out information. But we still kind of go about figuring out scientific knowledge in basically the same way. Now, when you were in middle school, or maybe even some of your earlier science classes in high school, you may have been told that the scientific method was a series of steps that scientists follow. That's a little bit of a misnomer. It's not really a set of steps. Let's call the scientific method more important things to consider and use trying to answer a question. It's actually a pretty good place to start. All scientists start with a question. Now, you may have heard that all scientists will experiment and they're going to do things in certain orders. And the reality is that there's some branches of science or some topics in science where it's very difficult to experiment on whatever it is you're trying to study. For example, if you're trying to study stars and distant galaxies, experimenting on a star in another galaxy is probably not possible. However, you can gather information in some way about stars and other galaxies, and that way you can make some determination by analyzing the information that you find. If you're a paleontologist and you're going to study fossil records, you're not really going to be able to experiment on fossils. However, you gather information about the fossils, and then you look at that information carefully to try to tell you something about organisms that might have lived a long time ago. So regardless, you're going to start with some kind of a question that you want to find an answer to, regardless of what area of science you're in. And you're going to collect some information. Or we'll call it data. That's a better term for it. And you're going to do that through observations. Now, there are two types of observations. The first is using your five senses to gather information or data. What do you see happening? What do you hear happening? Do you have information about what you feel with your hands about something? What do you smell or taste? Okay, we use our eyes probably more than anything else. What do we observe visually? But there are other ways to collect data, and sometimes, depending on what you're studying, what you smell or taste or hear can be also very, very important. We call this type of data qualitative observations, because we're describing the quality of things really through using our five senses. The other type of information or data we can collect are measurements. We need a tool of some sort in order to collect measurements. Okay, whether we be studying how much radioactivity something is giving off, whether we're using a timer to determine how fast something happens, whether we're using some type of a tool to determine how far something goes or how far away something is. All those require measurements, which means there's a number that we're going to associate with it. And so these are called quantitative. And the word quantity is the root here. In other words, quantity is a number, an amount of something. Again, this is quality and quantity. Those are the roots. Okay? So that helps you determine what's qualitative, what's quantitative. Okay, once you've collected your information in some type of a way, okay, another thing that you may or may not have before you start collecting information is a hypothesis. I'm not giving these in order kind of on purpose. We're used to seeing these in a particular order, but we may not see them in that exact same order when we look at a scientist's record of their work. A hypothesis often comes after some information has been collected. And a hypothesis it's a prediction of the results. It's based on two things. It's based on research, it's based on what we call prior knowledge, what we already know. Okay. It can be in an if-then format, but it doesn't have to be. Okay, that's what we're usually taught when we're younger, that we write a hypothesis. If this happens, then this will happen. But you can still make a hypothesis without actually using the if-then format. And then, of course, one of the major important things is what we call the conclusion, which is what patterns are occurring in the data. Or what relationships can be shown. So we look at when we start thinking about the word conclusion. Now, the part that I left out here is one common but not absolutely required part. Sorry about that. And that is designing of an experiment. If you are studying something and you're able to actually do an experiment on it, a controlled experiment can be an extremely valuable way of gathering information. An experiment is created usually after the question has been developed and a possible hypothesis has been developed. If you're going to design an experiment, after your research question, you have to ask yourself, what is the independent and dependent variable? Now, hopefully these terms are somewhat familiar to you, but I'm still going to review them because I see a lot of students continue to struggle with looking at a description or something about an experiment and making a determination about what is the independent and dependent variable. And a lot of times you get them mixed up with each other. The independent variable is something that is purposefully changed. And what we're hoping that it can affect or cause change in our dependent variable. The dependent variable is something that could change in response to the independent variable changing. One thing that's important to note that the term controlled experiment means there is only one independent variable. Anything else that's a possible cause of change to the dependent variable are held constant, which means they do not change. Very important when we're looking at an experiment, we can only ask one question at a time. Our question should be in the form of what is the effect of, we'll call it X, on Y. This is the X, the independent variable. This is going to be the Y. So I can ask myself a lot of different questions. What is the effect of hours of sleep on test scores? I could ask myself, what is the effect of diet on how often someone has an asthma attack? In each case, when I ask myself, what is the effect of something, that's the independent variable. When I say, what's the effect on this, that's the dependent variable. So X is hopefully causing a change in Y. That's what we're looking to see if it happens. Does X cause a change in Y? So since we only want to have one possible cause, there are other things. So if you happen to have asthma, there are a lot of different things that could cause someone to have an asthma attack. If I only want to study diet and how that affects an asthma attack, all the other things that I think might cause someone to have an asthma attack, I have to do my absolute best to make sure that those are not changing. So for example, somebody will say, hey, pollen, lots of pollen in the air could cause people to have asthma attacks. So if I'm going to study people eating certain foods or choosing to eat a certain way, I have to be careful and I have to watch how much pollen is in the air every day. And it has to be pretty much the same. Otherwise, I'm studying two variables. I'd be studying diet and pollen on the asthma attack. And that makes the answer to my question really difficult to figure out. So anytime you're designing the experiment, be really careful that you've only chosen one and only one independent variable. All the other possible causes have to be held constant. They're controlled. So we use the term controlled variables or the term constants to refer to any other possible independent variable that we're going to hold to have the same level or the same amount all the way through the experiment as best as we can. Now another important term when we're looking at experimental design is a control or a control group. This is a basis for comparison. Okay. A controller or control group is where the independent variable is absent or the amount of the independent variable, if we can't remove it entirely, is used to compare to other amounts of the independent variable. Not every experiment is going to need or have a control group or control. But you have to look at the situation very carefully and ask yourself, is there a control group possibility or is there a control? So for example, we talked about diet and the effect of diet on asthma attacks. So for example, if I'm studying, let's say, a vegan diet, does a vegan diet help people with asthma attacks? Well, your control group would be a group of people that also suffer from asthma that are not going to eat a vegan diet. That allows you to compare the people that eat the vegan diet, how many asthma attacks do they have, compared to people that don't eat the vegan diet, how many asthma attacks do they have. So that would be your control group would be the people that don't eat the vegan diet. And you're going to compare that to your independent variable, which would be people eating a vegan diet. Your dependent variable in that case would be perhaps the number of asthma attacks they have a day, a month, whatever you chose. So when you design your experiment, look over the experiment carefully and ask yourself, is a control group possible, or is there a control or some sort of an amount? I'm going to say, this would be, let's just call this the regular amount, and then I'll have more or less of the independent variable, and I'm going to compare it to this base or control amount to see if that makes a change in the dependent variable. Now, when we put together an experiment, at some point in time, we're going to have to organize the data. So organizing the observations. We usually organize in one of two ways: data tables and graphs. Those, in both cases, help to make it easier to see any patterns and relationships. If you're using a data table, your data table is going to have rows and columns. Important things to know that at the top of every column, we have what's called the header. That's basically just a little of information. That labels and tells us what's going to happen underneath it. The first column is usually where we put the independent variable. The second column is usually the dependent variable. You can have multiple dependent variable columns if the experiment is repeated. Or has what we call trials. Okay. When we start talking about graphs, we're going to limit ourselves here to two kinds of graphs. One's the bar, and one's the scatter plot. Scatter plot's also sometimes called a line graph. But the scatter plot is plotting the points. In some cases, you may or may not need to draw the lines. Just generally, in any graph, the x-axis is the independent. Sorry about that. Is the independent variable. Remember, that's this direction. And the y-axis is the dependent variable. It's this way. Always label the two axes when you're making a graph. Now, the last question is, when do you pick a bar and when do you pick a line graph? The bar graph is used when the independent variable is non-numeric. In other words, it's not numbers. That usually means it's categories. Or if no values in between the data points is possible. Okay, so if you're in second grade and you're running around, you're doing a bar graph because you're going to ask all of your friends what's their favorite ice cream flavor, you're going to choose a bar graph because the flavors, maybe you don't know how many people, what's the favorite ice cream flavor, so you're going to have the different flavors people pick, And then you're going to have how many people pick that flavor. Now there's chocolate chip and strawberry and Rocky Road are not numbers. So that means you're going to use a bar graph. You use a scatter plot. Or line graph is when both the independent and the dependent variable are numeric. Right? And if there's, just because you decided, let's say you're measuring you're going to take the temperature of a gas and you're going to figure out the volume of the gas. Now you're going to choose certain points to take at which you're going to take the temperature and the volume at the same time. But you don't have to point every single possible temperature, and it's possible there's like, if you pick like 50, and even if you pick 50 and 51, you could have 50.5. There's possibilities in between the data points. You're not going to put every single possible data point. That's just going to take too long. So if you put a line graph, that allows you to do what we call extrapolate the data in between the points that you actually took the data. Okay, so that for now, that's all I'm going to hold you responsible for when it comes to the scientific method.